Let's see this question. We want to evaluate this triple integration. So in z direction, the lower limit goes from 0 up to this square root of 1 minus x squared minus y squared. So the picture of this is the top semi-sphere, which actually is a unisphere, a ball, a uniball. So think about the x squared plus y squared plus z squared equals 1, right? That represents a uniball centered at the origin. So in z direction, the lower limit from 0, upper limit from this top semi-sphere. Then y direction. Y direction goes from 0 up to this semicircle, right? Because x squared plus y squared equals 1 is a unit circle centered at the origin. And in y direction, the lower limit goes from 0, upper limit goes from the square root of 1 minus x squared. So the top semicircle. Then x direction goes from 0 to 1, constant. So how do we evaluate this triple integration? We want to change the variables. So this x, y, z Cartesian coordinates, we want to use spherical coordinates. Basically, we want to change it to rho, right? Change the variables, rho, phi, theta. So what does it mean? So let's see the picture. So we have 3-dimension coordinates. Let's call this x, let's call this y, let's call this z. Then we have a point somewhere. We have x value, y value, and z value, right? So this is in Cartesian coordinates. So x value might be here. Right, so this is our x value. And y value. So this is our y value. And z value is our z value. Right? This is from the point of view of Cartesian coordinates. Another way of looking at these points as a point on a sphere, on a ball. So how do we imagine? Let's imagine this. So have this circle on xy plane. Then we have third dimension. So we think of this point as a point on the ball. It's a bad drawing, but just imagine this point, we look at it as a point on the ball. So we call spherical, we use spherical coordinates. So the coordinates would be rho, phi, theta. Rho is from the origin to the point, the length of this. So we call rho. You can think as 3-dimension radius. So rho measures from the center of the ball to the point on the surface of the ball. So that's what rho does. And phi measures the angle. Measures the angle this point formed with this origin we could call so measures this. So this angle we call phi. And then theta. Theta is the same theta as before, measures. So we drop this one, right? So radius measures this theta. So on the xy plane. So basically, if we remember polar coordinates, polar coordinates we have r squared equals x squared plus y squared, right? And then x equals r cosine theta, y equals r sine theta. That's from this picture. That's from this triangle. Right, from this triangle. So this is a 90-degree. Right. This is x value. This is a y value. This is r. This is r. Right. This is theta. So clearly from this right triangle, we see the relationships of x, y, and r, which is this. Right. And also r squared equals x squared plus y squared. But now, with this point, let me use green color. With this point, we can also drop this point onto xy plane. So we still have this relationship. We still have this relationship, but we even have more. This is a 90-degree. So we see clearly rho square equals to this r square plus this z square, right? So we have r square plus z square from the green triangle. And of course, r squared is x squared plus y squared. So rho square equals to x squared plus y squared plus z squared. And then we see x value. Well, this, right? So we have this phi. So this angle is a phi. And that means this angle is a phi. Right? So because of this, again, this green triangle gives another relationship. Z is this height of the triangle equals to rho times cosine phi, right? And also this r, so r equals to rho sine phi, right? So I have this relation. R equals rho sine phi from this green triangle, right? So now from this one, so this one we can rewrite as, so x equals r equals rho sine phi, you can write as rho sine phi, then cosine theta. Y equals rho sine phi cosine theta, right? So now we see xy, so in xyz, change xyz variables to rho phi theta variables, we'll have this relation. We have this one, x equals to rho sine phi cosine theta, y equals to rho sine phi sine theta, and the z equals rho cosine phi. All right. So yeah, that's just a review of changing Cartesian coordinates to spherical coordinates. So obviously we want to change those variables to spherical coordinates. And so dz, dx, dy, when we integrate this 3 dimensions, and we can do some calculation. Basically change our variables. So if we call this t, right, then we can calculate the dt. And specifically, we can get the determinant of dt. And the absolute value of the determinant of the dt will be called Jacobian, which means that so absolute value of the determinant of dt, which is a matrix, a 3x3 matrix. Then we change the variables to d rho, d phi, d theta. So we're going to use this, right? We're going to change the function f of x, y, z, of course, into f of x is r a rho sine phi cosine theta, and y is rho sine phi sine theta, and z is rho cosine phi. So we want to change the variables of the function from x, y, z to rho phi theta, and also change the variable from x, y, z to rho phi theta. And also, right, the difference between those two integrations is this determinant of the dt of the transformation. and we call Jacobi. All right, if we do the calculation, that's the determinant of partial x, partial rho, partial x, partial phi, partial x, partial theta, then partial y, partial rho, partial y, partial phi, partial y, partial theta, then partial z, right? Partial phi, partial rho, partial z, partial phi, partial z, partial theta. And then you go through the process. I'm going to skip. And in the end, we'll get a rho square sine phi. All right, so the Jacobi in between those x, y, z coordinates and phi and the rho phi theta coordinates, the Jacobi is rho square sine phi. So we're going to use these relations into this triple integration. Let me erase this. So we're going to change variables. And the beauty with the spherical coordinates is once we change the lower limit and upper limit, we get a constants. Right? So the half semicircle, so look at this, look this, the lower limit and upper limit in each variable. So if we have 3, right, we just get this quarter sphere. If I could draw, we just get this quarter sphere in the positive side. If you look at your room as it, right, look at this is like one corner of your room. We just get this quarter sphere. So in this quarter sphere, the lower limit of upper limit, so let's see x direction. If we fix x direction, it goes from 0 to 1, right? That's 0, that's 1. Then y direction, right? So this is 0 to, so this is the x direction. This is y direction. This is z direction. Oh, right. I don't have to rewrite it because we have here already. Let's just rewrite it for spherical coordinates, right? For spherical coordinates, we know rho, so let's write those 3, rho, phi, theta. So in rho direction, right? It just go, lower limit goes from 1, lower limit goes from 0, upper limit goes from 1, because it's a unit sphere, right? So this tells us the unit sphere. Then rho direction, in phi direction, it just goes from 0 to pi over 2, right? Usually phi is defined, goes from 0 to pi, but this is above xy plane, so 0 to 2 pi over 2. In theta direction, also, it's just a fourth quadrant. Theta also goes from 0 to pi over 2. So the beauty is this, when we change the coordinates, with the lower limit, upper limit, all becomes constant, right? Now the function square root of x squared plus y squared plus z squared, just rho squared. Just rho square root, which is a rho. Then the denominator is 1 plus x squared plus y squared plus z squared, rho squared. Then rho square become rho to the fourth power. So plus rho to the fourth power. Then Jacobi is rho square sine phi. Right, rho square sine phi. Now we see the integration is easy. Right. Let's change the red color. So rho times rho square, that's rho cube. Then plus 1 over rho to the fourth power. Then we have sine phi, d rho, d phi, d theta. So let's just rewrite this. So theta direction, no, I wrote this in wrong direction. Okay, hold on a second. So I wrote in wrong order because my outside layer I want to be rho. So this is d rho. And second layer is, let's call it d theta. And this layer, let's call it d phi, right? So we want rho goes from 0 to 1. Then theta goes from pi over 2, 0 to pi over 2. And phi direction also goes from 0 to pi over 2. And we see the integrand. The integrand is independent from theta. So theta direction, we just go ahead and calculate. It's just pi over 2 minus 0, which is pi over 2. Okay, theta direction, right? Let's use the blue color. So theta direction just goes from pi over 2, and the integrand is free from theta. So we just get in theta direction, we just get pi over 2. And in phi direction, well, negative cosine phi, right? A negative cosine phi, the derivative is positive sine phi. It's a negative sine, which become positive sine phi. So in phi direction, we get negative cosine phi. And we want to evaluate from 0 to pi over 2. Then in phi direction, well, let's use u substituting. Let u be 1 plus rho to the first power. Then du will be 4 rho raised by 3 d rho. Right? So we have rho to the third power and d rho, which is missing this 4. Missing this 4. Then we multiply quarter on the side. So we multiply quarter outside. Then we integrate this rho cube divided by 1 plus rho to the first power. Right, that just becomes 1 over u. Right, so this is then 4 rho cube d rho, that's du. So 1 over u is the u raised by minus 1. So we get a u raised by u. The 1 over u just ln u. Right, ln u. So in phi direction, we just get ln of u. ln of u, right? Remember, if we do ln, if we take derivative of ln x, that's just 1 over x. In this case, we get du over u, which is 1 over u du. 1 over u, that's just ln u. Well, what's u? U is 1 plus rho to the first power. And in phi direction, in rho direction, we want to evaluate from 0 to 1 also. Well, quarter times over pi over 2, this is pi over 8. Then multiply by negative cosine pi over 2 is 0, right? Then negative minus cosine minus negative cosine 0. Cosine 0 is 1. Minus negative 1 become plus 1. Then ln 1 plus 0, this is ln 1 equals 0. Then ln 1 plus 1 raised by 4. 1 raised by 4 is 1. So it's just ln 2. And that's it. So simplify. So we get a pi over 8 ln 2. And that's it.